For this video, I'll be working through question 3 of the 2017 Level 2 Mechanics exam. Right, question 3, circus dancer. A uniform wooden plank of mass 5 kgs and length 6 meters is resting in the hands of two circus employees, Alf and Barrett. Sally, a circus dancer, mass of 40 kgs, goodness that's light, stands 2.5 meters away from end A of the wooden plank as shown above. On the diagram below, draw and name all forces acting on the plank. Right, so we're going to have, where is Sally? There's Sally, 2.5 meters away. So we're going to have FG of Sally, and she's going to be substantially more than the plank. She's 40 kgs and the plank is 5 kgs. So that's FG of Sally. And the center of the plank is probably somewhere here-ish, at a guess. FG of plank. And we have the support force of Barrett. Just put that up here. FS of Barrett. And we have support force here of Barrett, not Ernie, Alf. FS of Alf, ELF. Right, so they are the 4 things that are happening. Notice I put the mass of the plank acts through the center of gravity, which is literally the center of the plank. Okie dokie. Now, the plank is in a state of equilibrium, with Sally standing 2.5 meters away from the end of plank, from end of A. Describe the conditions needed for the plank to be in an equilibrium state. So the anti-clockwise torques, or we'll go with clockwise torques first. Clockwise torques must be equal to the anti-clockwise torques. Anti-clockwise torques, i.e. I should really just do the sigma or whatever, torques equals 0. I'll put that. Yeah, sum of the torques equal to 0. Calculate the total torques around the plank, total clockwise. I'll just quickly highlight that, around end A. So, in other words, here's A. That's clockwise, that is not, because it's anti-clockwise. So it's literally just Sally and the plank. So we'll go torque clockwise. I'll just forget about point A. We'll just make that it's around A, so it means it is going to be Sally. So force torque is right over here. Force times distance, and that's perpendicular force as well to the distance. So, Sally, how heavy is she? She's 40 kgs times 9.8. That's mass times gravity, which gives you the force. Times she is 2.5 meters from A. Plus, plank is, how heavy is a plank? 5 kgs times 9.8 times 3 meters, because the mass acts bang smack in the middle, and that'll give me, what will that give me? 1127 Newton meters. Round that up to 2SF. Gives me 1100. We see that Newton meters of torque around point A. Next question. Calculate the size of the force experienced by Alf, who is holding end A of the plank. They've given you a whole heap of room over the page to do this question. I'll do it over the page just because why not, but you don't actually need that. Well, I don't really need that much room. There's a few ways to do this. You could start from scratch and say the anti-clockwise torques equal to the clockwise torques, and work it all out that way, or you can do the quick and dirty way. How are we going to do it? I'll start it off and then I'll talk it through. So here we have these clockwise torques are going to be equal to this anti-clockwise torque. In other words, if we find out the force of B, we know the force of B plus the force of A is going to be equal to these two forces. think of it this way. If you're too heavy for like a set of scales, you get 2 sets of scales. You put 1 foot on the other, 1 foot on the other one, and you just literally add up the weight. There'll be different amounts on each scale, but still the support force has to add up to whatever force it's supporting. So in other words, figure out what was that, Barrett, how much he's lifting, and then Alf lifts the rest. So let's figure out how much Barrett's lifting. We know that he has to counterbalance the clockwise torques, so his force is going to be equal to was it 1127 from over the page, divided by he's 6 meters from Alf, so that is going to be left with, how much is that? 187.833 newtons. That's how much force Barrett is providing, which means force of Alf is equal to force of G of Sally plus the force of G of the plank, or just put P for plank, why not, minus force of Barrett, which is pretty self-explanatory. 40 times 9.8 plus, was it 5 times 9.8 minus 187.833 equals, how much does that equal? 253.16 newtons. 2SF, remember, so it's going to be 250 newtons. There we go, and that is the force of Alf. There we go. Oh, it's A, not E. There we go. Explain whether Alf experiences any change in force when Sally moves from her existing position towards end B during her routine. So let's just, straight off the bat, if she is here, at the moment, Barrett's already carrying the team. He's carrying more than Alf. We can see that up here. Hold on, take that back. So I'll just quickly redo this one here. Explain whether Alf experiences any force when Sally moves from her existing position towards NB during her dance routine. So I just completely got these two confused. Sally is closer to Alf, so Alf is carrying the team, not Barrett. When Sally moves closer to Barrett, Barrett starts carrying more of Sally, and Alf starts carrying less of Sally. That's why over here, Alf is supporting 250 newtons, whereas Barrett's only supporting 187, because Sally is on the left-hand side of the center point. So I'll just write this out and then discuss it. Right, so what I've said is Alf would feel a decrease, that's not how you spell feel, feel a decrease in force, pivoting, so full stop, pivoting around B, so if you're pivoting around here, the force of A anti-clockwise times the distance is equal to the force of Sally times the distance plus the force of the plank. So I've said that here. As Sally moves closer to B, the net anti-clockwise, because this is anti-clockwise and this is clockwise, the net anti-clockwise torque decreases around B, causing a decrease in force on ELF. Right, so last question. During one of our dance routines, Sally is spinning a ball around her head in a horizontal circle as shown above, or below I should say. The ball has a mass of, 50 grams, makes 5 rotations in 4 seconds. The length of the string from the ball to Sally's hand is 0.6 meters. Calculate the size of the force experienced by the ball during these rotations. So it's circular motion. So we use our formula for circular motion, which is Fc equals mv squared over r. We have the radius, we have the mass. What we're trying to do is find out the velocity. So 5 rotations in 4 seconds, which means it's doing one rotation in just under a second. So you go 4 over 5, and that is equal to 0.8 seconds for one rotation. How do I spell that? There we go. So now what we're going to do is velocity equals distance over time, which equals 2 pi r to get right around the whole circle, divided by the time it takes to get round. Fc equals m bracket, let's go 2 pi r divided by time bracket divided by the radius. And I'm not going to write those out. I'll just plug that into your calculator, and that'll give you 1.8. No, it won't. 85 newtons, and we need to round that up to SF. So that's going to be 1.9 newtons.